Today was just the introduction lesson to our exponential functions. I was hoping that you would go into Desmos and just see some of the different things that happen when you change the multiplier. The first one, if you have a decimal multiplier, notice how your line is decreasing. In this case, we're going to talk about, tomorrow, we're going to learn about this y-intercept. How does that show up in our equation? And notice that this is a decreasing one. When I have a multiplier that's that's a decimal. If I make a multiplier that's bigger than 1, then all of a sudden I'm getting an increasing 1. My y-intercept still here is 1. Now this right here is called an asymptote when it gets closer and closer and closer to a line, but it approaches it but doesn't touch it. That's called an asymptote. And when the multiplier was a negative, the asymptote was also the x-axis, or when y is equal to 0. These are actually called our exponential relationships. The rest we're going to talk about, but we don't consider them exponential. So when we start talking about exponential relationships, we always say when b is greater than 0 and not equal to 1, because technically those aren't exponential. If we look at exponential relationships, they have an asymptote. They have a y-intercept, they're curved, and they're going to have a multiplier. So when we get to a multiplier of 1, the reason this is not exponential is notice it's just a straight line, which makes sense. If my multiplier is 1, nothing's changed. So we get into some interesting ones here when we have a multiplier of 0. If you notice, when I click on here, I have a point right here. And that's because the big discussion is anything to the 0 power is 1. So even 0. So there's this big discussion that mathematicians don't agree on, whether this point exists here or not. Some people say 0 to the 0 power is 1. Some mathematicians say that 0 to the 0 power is undefined. So either way, it shows up weird in the graph. And then notice anything times 0 is 0. So there's just a straight line. This is not exponential. And then when we get into a negative multiplier, we get some weird stuff. Notice these dots are going, and there's these dots, and we get some that's increasing, some that's decreasing. And that has to do with taking something, a negative number to a power. So negative 2 squared is 4. So that's going to be a positive, but positive 2 squared, or right here, negative 2 squared is 4. And positive 2 squared is 4. So you're going to get these things that are going back and forth, back and forth. And then if I take it to a negative exponent, we're going to find out more about, what happens when we have these negative exponents. But when my multiplier is a negative number, it actually goes back and forth because odd powers give me negative numbers and even powers give me positive numbers. So again, that's not exponential. The only two that we're really going to look at are these two. So when we go into our notes, I've filled those in for you, and you can make a copy of them or whatever. I just am really interested in these first two. That asymptote for this is when this should be y equals 0. And right here for when y is equal to 0. That's going to be our asymptote. And then when you get to the bottom, the exponential equations are only defined for b values greater than 0. So tomorrow's lesson, we're going to explore what that a is and what the b is. I think you have an idea already. We've talked a little bit about it with geometric sequences.